Hello and welcome to this recorded e-learning module about AXI design conversion. My name is Frank Nelson. I'm a Xilinx technical trainer and course developer. I'll be your instructor for this module. After completing this module, you'll be able to explain what the AXI protocol is, identify the advantages of the AXI protocol, and list the various AXI-based system architecture models. AXI is a product of ARM, a company that designs and markets processor and peripheral IP to silicon vendors. ARM provides a couple different digital highways, which are advanced microcontroller bus architectures. Of those, ARM provides AXI is one of the most flexible and powerful. Over the years, ARM has introduced various releases of its AMBA protocol interface to describe interconnect between the processor core and peripherals. This protocol has been abstracted away from the user. Generally, this makes building your system easier. Now, Xilinx FPGAs enable peripheral designers to build with the AXI interface standard. AXI is an interface and protocol definition. It is not a bus standard. This has the benefit of providing a flexible interface without as much architectural overhead as you'll see. It also allows you to build an optimal embedded system. Now, currently it's pre-production in the EDK 12.3 release, and we'll discuss what that means in a moment. And it currently only targets the Microblaze soft processor core, and it's only for Spartan 6 and Virtex 6 device families currently. Most EDK peripherals will support AXI with the EDK 13.1 release, but right now it's a little limited. A common question is, who should migrate the design to AXI? Well, currently anyone that believes the features are beneficial. The PLB-v46 bus standard will be around for a while longer, but you probably want to target AXI if you want to migrate the design to the next generation device families after Spartan 6 and Virtex 6. But if your design is only going to use Spartan 6 and Virtex 6, then you're fine using the PLB-v46 bus standard. ISE Design Suite 12.3 is a pre-production release for designs that are going to use the AXI IP peripherals. The AXI IP in this release have not completed qualification for use in final production designs. Some wizard functionality in the Xilinx Platform Studio does not yet fully support AXI-based designs as well. For ISE Design Suite 12.3, pre-production status applies only to designs making use of the AXI IP peripherals. You can still successfully create and implement embedded and non-embedded AXI-based designs using ISE 12.3. It's just the IP that may have a concern. The AXI Interface Specification does not define the use of the interconnect. In fact, there are 3 different configurations that Xilinx supports. Of the available configuration, there is Memory Map, which is a full configuration, much like the PLB-v46 bus standard. There's also a Stream configuration that targets applications that require streaming data. And there's also a light version that is a simple interface that reduces the required architectural resources. This is especially beneficial to FPGA users since each device has a limited fabric available. In this example, the designer has replaced a PLB-v46 shared bus with an AXI implementation that has some common operational properties. This was helpful because the application was a robust system that required many peripherals with multiple masters. Part of the reason Xilinx is using AXI is because it enables designers that already use the PLB-v46 to easily build a robust embedded system. If the system did not require as many peripherals, then the benefits of AXI become more readily apparent, as these systems would require much less hardware than a PLB-v46 bus system. So why should you consider using AXI? Well, it offers higher performance, and this is because AXI allows systems to be optimized for the highest max frequency, lower latency, as well as maximum throughput, or some combination of those attributes that the user selects. This flexibility will enable you to build the most optimized product for your market. It's also easier to use. Because it consolidates a broad array of interfaces into the AXI standard, you only need to know one family of interfaces, regardless of whether they are embedded, DSP, or standard logic users. This makes it easier to integrate IP from different domains, as well as developing your own custom IP peripherals. It also enables ecosystem sharing, so since partners are embracing the move to AXI, it's an open, widely adopted interface standard. Many of them are already creating IP targeting AXI or other AMBA interfaces. This gives you a greater catalog of IP in which to choose from, and this will ultimately lead you to a faster time to market. One of the goals of the Xilinx implementation of AXI is a unified interface protocol of Xilinx components. There will be a migration towards AXI in all facets of Xilinx IP and components. This will allow you the flexibility to rapidly define and interconnect standard and custom components, thus reducing the learning curve to various technologies you may want to target. This slide just shows how Xilinx is offering 3 different AXI configurations currently. They are Memory Map, Stream, and the Lite version. The Memory Map is best used in applications that use the PLB-v46 bus or the PCI core in the system. The Streaming configuration suits applications that require bursting of data. The Lite version is best used in embedded applications that have only one peripheral or use the older PLB bus standard. Rebuilding the embedded system when doing your design conversion is usually best, but I want to note here it's not difficult because using EDK is not difficult. Simply put, adding processors, buses, and IP has literally been drag and dropped for as long as EDK has been around. However, most embedded customers are building some custom IP into their application, and this can have some challenges. If the IP you had built from a previous design was built with the IP wizard, the IP can be migrated using the templates provided in the following solution record. So you can go to our solutions database on support.xilinx.com, and you can go look this up and find all those necessary files. If the IP cannot be altered to AXI, all you need to do is just add the AXI to PLB bridge component, and this is described in the Xilinx AXI reference guide, which we're going to get into in a moment. If the IP was built from scratch, you can refer to the memory mapped IP feature adoption and support that's also in the Xilinx AXI reference guide. Now, as I mentioned, the Xilinx AXI reference guide, or user guide 761, denoted UG 761, is a very good document that will describe and answer most of the common questions that new users and new adopters will have. First of all, the AXI usage in Xilinx FPGAs is described. It introduces key concepts of the AXI protocol. It also explains what features of AXI Xilinx has adopted. It also has a PLB to AXI migration guide, which is a handbook for existing embedded customers to learn how to migrate their custom IP. And we also describe how to create and import AXI IP, how to debug and verify designs with ChipScope, and how to convert PLB-based IP to AXI IP. It also discusses the ARM specifications to some extent, but not very much. In general, if you want that kind of information, particularly as it pertains to AMBA AXI protocol version 2.0, or the AMBA 4 AXI 4 Stream protocol version, you'll need to go to the location you see here at Info Center. And that will answer all those questions and define those common ARM specifications that makes it an industry standard. So in summary, AXI is a signal interface protocol, not a shared bus standard. And likewise, since we have those 3 different versions, this is going to save you a number of device resources and help you to optimize your design to get better performance. AXI offers higher speed, ease of use, and has the support of many of our business partners. The AXI protocol has 3 different configurations. There's the memory map, we're full for OPB v46 replacement for full embedded systems, streaming for data streaming applications, and Lite for simpler systems. You also should get familiar with the Xilinx AXI reference guide UG761. It contains more details about the AXI protocol and explains how to migrate your system to AXI. Besides our free AXI RELs that are available on our webpage, we have 3 different courses. We have our Embedded System Development course and our Advanced Features and Techniques of Embedded System Design, which are targeted more towards hardware developers, as well as our Embedded System Software Development course, which is really targeted more to software developers. But note here, whatever you do, please take a second and let us know what you thought of this REL. Just click on the icon at the top of the page and tell us what you thought. Again, my name is Frank Nelson, and we appreciate your business.